Let's break this question down into two, and I can have a little cup of hot chocolate in between. So ethanol can be used as a fuel. Information, ethanol is being used as a fuel. Determine is our key term here. Figure out for yourself. The enthalpy of combustion. Okay, combustion is when I take a fuel and I react it with oxygen and I make carbon dioxide and water. This is combustion. I'm looking specifically at the combustion of ethanol. 298 Kelvin, so normal conditions. Using the values in the data booklet, I had a data booklet I could look at. Here's the key thing: assuming all reactants and products are gaseous. If I am looking at the combustion and all of the products and reactants are gaseous, then for this question I have to use bond enthalpies. That's the information that I have to use to answer this question, because assuming all reactants and products are gaseous. Usually we can burn fuels and the fuel could be as a solid or it could be as a liquid. If we were to do that, then we could use enthalpy of combustion data. But in this particular example, we are told that we are assuming all reactants and products are gaseous. So what would I do? I would have ethanol. So I've got ethanol, which is 2 carbons, let's make that correct, 1 OH group. Okay, basic, simple, common formula that we have looked at and that you should have looked at during your lower school years. If you don't know the formula of ethanol, you're not going to be able to determine this, because you would not know which bonds have been broken. So ethanol is turning into carbon dioxide and water. First thing that we would need to do here is balance the equation. So I'm going to need 2 carbon dioxides to match the 2 carbons that I've got here. I'm going to need 3 waters to match the 1, 2, 3, 4, 5, 6 hydrogens I've got here. And then I'm going to need to add in my oxygens for the combustion, remembering to keep them on the left-hand side of the reaction. And that's going to take me to having 1, 2, 3 oxygens here, plus 1, 2, 3, 4 oxygens here, so that gives me 7 oxygens. And over here I'm going to need 7 oxygens in total. I already have 1 oxygen here, so then I've got 6 oxygens that I need left to account for. So 3 O2s would give me that 6 oxygens that I was looking to include. Tidy that up a bit. Then we have to look at what bonds are made and what bonds are broken. So I've got carbon-hydrogen bonds. I've got a carbon-carbon bond. I have got a carbon-oxygen bond, and I've got an oxygen-hydrogen bond. Let me check. An oxygen-hydrogen bond, I've got 1 of them. Carbon-carbon bond, I've got 1 of them. Carbon-hydrogen bonds, I've got 1, 2, 3, 4, 5 of them. And then a carbon-oxygen bond, I've got 1 of those. These are the bonds that are broken. Then I look on my other side and I'm thinking, okay, no I don't actually, I've missed out all my oxygens. I've got oxygen bonds. I've broken 3 of them. Okay, now let's go over to the other side. What bonds have I got? I've got carbon-oxygen bonds. I've got oxygen-hydrogen bonds. What else have I got? Nothing. That's it. That's all of them. So how many? I've got 1. I've got 2. But because I've got 2 carbon dioxides, I've got 4 of those bonds. And then here for my waters, I've got 1, I've got 2, but I've got 3 lots of waters. So I've got 2 times by 3. That gives me 6 OH bonds. These are the bonds that are made. Now I have to look at my overall. So the bonds that I have got broken minus the bonds that were formed or made. If I calculate the bonds that I have got broken and I calculate the bonds that I have formed, and I take those values from the data booklet, then I should end up with a value of, ooh, the sheer excitement, should end up with a value of plus 1040. Now for this one, I'm not going to go to the data booklet and find all of these values for you. I'm going to ask that you go and check those yourself and check that you come out with a value of 1040. I'm now going to have a hot chocolate and move on to the next.